Sider Progetti's sheet coil packing line that you are now seeing is completely automatic and requires the assistance of only 2 operators. The coils to be packed, coming for instance from a painting or galvanizing line, or from other processing lines, are first arranged at the line entry section and laid on waiting saddles. From now on, the coils will be handled automatically until packing operation is automated. A first car takes the waiting coil and places it on a measuring saddle that reads the coil sizes and transmits them to a central control unit that controls the whole packing line and supplies the commands to give the proper form to the packing components according to the coil sizes. The presence of the coil on each saddle is sensed by photocells and transmitted over to the central control unit that organizes the work of the first car. A second car takes the coil off the measuring saddle and transfers it towards a paper strip wrapping machine after rotating it 90 degrees. The wrapping machine closes around the coil and prepares itself for the radial binding. In the wrapping machine, a shuttle runs along a circular guide. The shuttle carries out the radial binding with its onboard mounted paper or plastic film roll. During the binding, the second car, by means of driven rollers, makes the coil rotate 360 degrees around its axis. A plastic film of the same width as the coils is now wrapped around the coil circumference so as to give the paper wrapping a higher sealing function and protection. Once the wrapping operation is automated, the operator cuts the paper or plastic film strip. After wrapping, the machine opens and the coil is placed by the second car between 2 supporting hooks before being picked up by a third car. Soon after size measuring of the coil, the central control unit has processed the size data and started the preparation of side discs, outer mantle, and inner protection, or eye sleeves. The discs are prepared on a first line, which is arranged crosswise to the main line, starting from the square sheets. The sheets are available in 3 different sizes, so as to reduce the cut-off scrap, according to the outer diameter of the coil to be processed. Then a car-mounted sucker head picks up a sheet from the sheet pile, selected by the central control unit according to coil size, and rests it down on the first station of a twin-bar walking conveyor. The square sheet undergoes then a cutting operation to form a circular crown, whose inside and outside diameters are assigned by the central control unit. A plasma torch carries out the cutting while the sheet is rotating on its axis. During the cutting operations, the cut-offs gather into a scrap box placed under the sheet resting table. After the cut, an inner and outer roller flanging of the rims follow. The disc is clamped radially and rotated around its vertical axis. The outer edge is bent by flanging rollers that progressively change their angle, whereas the inner edge flanging is obtained through drawing. When the edge flanging is terminated, the disc is put on a disc mounting plate, waiting to be applied against the coil that is being processed. In the meanwhile, a second crosswise arranged line is preparing the eye sleeve and the outer mantle required for the protection of the internal and external cylindrical surfaces. Their preparation starts from sheet coils that are available in two different sizes in order to minimize scrap cutoffs depending on the width of the coil to be processed. A double mandrel swiveling reel, following the command from the central control unit, places either of the two packing sheet coils against a magnetic belt conveyor that uncoils the sheet, which is soon after trimmed along its two side edges. A cross shear cuts alternatively the sheet to length, according to the portions required for the preparation of eye sleeve and outer mantle. The first portion is conveyed towards a roll bending machine that bends it to form a cylindrical sleeve, which is later taken by a sleeve inserting mandrel for the following application into the coil's eye. The second portion, required for the outer mantle, is conveyed by the magnetic belt conveyor, properly aligned, and then brought towards the station where it will be applied over the coil. The coil, which is now placed on a pair of supporting hooks, is taken by a third car and brought to meet the disc inserting unit and the sleeve needling mandrel. The sleeve is inserted from one end into the coil's eye by the sleeve needling mandrel. In the meantime, the disc inserting plate applies the first disc. Then, the third car turns the coil 180 degrees for the insertion of the second disc, which has meanwhile been placed and centered on the disc inserting plate. Once the application of discs and sleeve has been completed, the car turns the coil a quarter turn and places it onto a mandrel of a carousel-type handling unit. After the car has left the coil, one end of the mantle sheet is laid against the upper center portion of the coil and fixed to the coil itself with a radial strapping applied by a first strapping machine. The carousel mandrel operates then other 72 degrees stepwise successive rotations, during which the mantle is progressively wrapped around the coil, and at whose single completions a radial strapping is applied to further tighten mantle, sleeve and discs against the paper-wrapped coil. Soon after the last strapping, the mantle is pressed against the coil to grant a perfect grip to this. When the radial strapping operation is finished, the mandrel-equipped carousel rotates 90 degrees and places the coil close to another strapping machine. Here, the coil receives 3 circular strappings, one of which around the center line and the other 2 ones around the edges to give pressure against the disc rims. Once the circular strapping is ultimated, the carousel makes another 90-degree rotation, after which a 4th car picks up the packed coil and places it on the waiting saddles. According to the inputs coming from photocells, the central control unit assigns the car the position of the free waiting saddles. At this stage, the coil is packed and ready to be either shipped or stored. The packing type you have just seen, which is most suitable, for example, for heavy overseas transport, includes the complete waterproof wrapping, the internal, lateral and external metal sheet covering, the complete internal, external, both radial and circular strapping. Other intermediate types of packing are possible according to shipment requirements or customers' requests. The one being shown here, with no eye sleeve nor outer mantle, is a heavy type packing suitable for inland transport. A light type packing with no discs, eye sleeve and mantle is suggested for shorter ways. The packing type will be determined whenever each coil enters the line and is transmitted to the central control unit that consequently controls all operations. While a coil is under completion, several other ones are being processed for packing along this line, which reaches a capacity of 12 pieces per hour.